All right, so chapter 4 is all about triangles, nothing but triangles. So we're going to start section 4.1 by naming the different types of triangles. So we classify triangles by one of two ways. We look at their angles or we look at their sides. Some of these you have seen before, some of them might be new. 360-degree angles, meaning every angle is exactly the same. Because angles are the same, it's equiangular, and I can't fit that on one line. If there's one right angle, that means it's a right triangle. If all the angles are less than 90, any angle that's less than 90 is acute. So if the angles of a triangle are less than 90, it's an acute triangle. Having one angle greater than 90, any angle that's greater than 90 is called an obtuse angle. So an angle greater than 90 in a triangle makes it an obtuse triangle. Three congruent sides. Three congruent sides are equilateral. So when you're looking at three congruent sides versus three congruent angles, notice the equa prefix on both of them. That means equal, angular for angles, lateral for sides. Two congruent sides, and something to keep in mind for isosceles. Two congruent sides is isosceles, but three congruent sides is also isosceles, as long as you have at least two congruent sides. And then no congruent sides, meaning everything's completely different, is scalene. So let's start naming some triangles. So we have this triangle here. Anytime we name it, whenever we named an angle, we used an angle symbol. Anytime we named a line, we used a line symbol. So to name a triangle, we're going to use a triangle. And then since there's three letters, let's use all three letters. Now, it has absolutely no importance as to which order those go in. I could have also switched the Q and the R, or the Q and the S, or switched all of them around. As long as you name all 3 points and you have the triangle symbol, you've named that triangle. So the anatomy of a triangle, what we want to look for are angles that are same or different, and sometimes we'll see marks in the corners like that. These two have congruent sides. Since they have congruent sides, it's called isosceles. So an isosceles triangle has two congruent sides, and the angles across from them I already marked to be congruent. Isosceles triangles have a pair of congruent angles and a pair of congruent sides. So let's take a look at this. Find the measure of each side of equilateral triangle RST. So equilateral, let's re-underline that so it actually underlines it. Equilateral triangle RST. Let me find an equilateral triangle in here. Here it is. We're going to pretend that's equilateral because it actually isn't. But equilateral tells me that all three sides are the same. I need to label it. Let's call this R, S, and T. And we know RS is 2x plus 2. We know ST is 3x, and we know TR is 5x minus 4. So, since it's equilateral, our goal is to find x first. Well, we have the congruent marks. I could take any of these three sides, any pair of those three, and set them equal. I'm going to pick RS and ST. So 2x plus 2 equals 3x. And one step to solve, subtract 2x from both sides, and you get 2 as x. So now what I'm going to do is I'm going to take 2 and I'm going to plug it into any of the sides. This one here looks the easiest. So all three sides are 6. Now we have an isosceles triangle. Let's go back to drawing that triangle because that was an isosceles triangle. And there's a special keyword here. Angle L is the vertex angle. The vertex angle is the angle between the two congruent sides. So the vertex angle, if I mark these two to be congruent, angle L has to be up here because it's between the two. So let's call this M, and let's call this N. LM is 3x minus 2. LN is 2x plus 1. and mn is 5x minus 2. Now, when we do this problem, we have to be careful of what we set equal. Because these two are the only two marked congruent, those are the two that I have to use for my equation. I'm going to subtract 2x from both sides. I'm going to add 2 to both sides and get x is 3. Now that x is 3, it says find the measure of each side. So I actually have to plug this in twice. I have to plug it into either one of these two isosceles sides and this third side. So when I plug it in, 2 times 3 plus 1, that's 7. If I were to plug it in over here, I should get 7 also because we did set them equal, and 9 minus 2 is 7. And down here, 5 times 3 minus 2, 15 minus 2 gets us 13. So we have our three sides of 7, 7, and 13. Our third example, we have a triangle again, same idea, same isosceles triangle, and it tells us which ones are congruent. KJ and LJ are the same. Since they both have the letter J in them, J is my vertex angle, and we have KJ congruent to LJ. Now we have some comparisons that we have to look at. JL is 5 less than 2 times the number. Let's make that number x. 2 times a number is 2x, and 5 less than means take away 5. JK is 3 more than a number. Well, more than just means plus. KL is 1 less than the number. 1 less than means minus. My overall goal, and remember, underline this to help yourself out, find the perimeter. And instead of underlining it, I'm actually going to highlight it just so we can see it as we're going through. Find the perimeter. So these two are the congruent ones, JK and LJ. 3 plus x equals 2x minus 5. 2 steps to solve, I bring x over to the right hand side, and I'm going to add 5 to both sides, and I get x is 8. Remember, if you need to show those steps, show them so that way you're not having any trouble. Once I know x is 8, I'm going to go ahead and plug it back in. 2 times 8 is 16 minus 5. This side over here is 11. Because I set them equal, I know this one's 11 also. And let's take my 8, plug it in down here. 8 minus 1 is 7. So I need to find perimeter. That's what it's asking for. Perimeter is the sum of all the sides. 11 plus 11 plus 7. 22 plus 7 gets us 29. So we need to classify this triangle now with vertices given below. So if I were to look at this on a graph, I would have 3 points that I could connect and graph. I'm going to name this point A, this point B, and this point C. What we actually have to do is we have to find the distance from A to B, distance from B to C, distance from A to C, and we have to see are any of them the same so we can determine if it's scalene, isosceles, or equilateral. So to find all of these, I have to use the distance formula. So distance formula isn't going away. Here it is in case you need it. I'm going to find AB first. AB is using these two right here. So x2 minus x1 squared plus y2 minus y1 squared. And when I go ahead and simplify, I got 7 minus 1 squared, which is 6 squared, so that's 36. And 11 minus 2 is 9, that's 81 when you square it. And 36 plus 81 is 117. So I have one of them now. I'm not going to simplify, I'm going to leave them as is, which will be nice for some of you who don't have to make factor trees. But now I'm able to just compare them. I don't need the actual distance. So let's do BC, which is x2 minus x1, 13 minus 7 squared, plus 2 minus 11 squared. And when I simplify, 13 minus 7 over here in this first parenthesis is 6. Let's square it and get 36. And 2 minus 11 is negative 9. And remember, when you square something that's negative, it becomes positive. Those end up being the same. So we already have two sides that are the same. What I need to look for now, is this third side going to be square root of 117, making it an equilateral triangle? Or is my answer going to be isosceles because only two are the same? So using A and C, I'm using the first and last one, x2 minus x1, and y2 minus y1. 13 minus 1 is 12. When you square it, you get 144, and 2 minus 2 is 0. Squared is 0. And the square root of 144 is just 12. So because I have two sides that are the same, because two sides are the same, it's an isosceles triangle. If you had no sides the same, it would be scalene. If you had all three, it would be equilateral. And let's try this last one. So we have this student, Arthur, who cuts a rectangular piece of paper in half along the diagonal. So here's my rectangular piece of paper, and what I'm going to do is I'm going to cut this along the diagonal to form two triangles. I need to classify the triangles. Well, because it's rectangular, I know this side is not the same as this side. So I'm going to call them A and B just because they're two different letters. Now, because this side is the hypotenuse of that triangle, it's a different one. So they're all different. Since they're all different, that means it's going to be scalene. So it's scalene. What I need is I want to classify it by angles and sides. So sides, I already know it's scalene because they're all different. What I want to look for is angles. I have acute angles, I have right angles, I have obtuse angles. When I look over here, if you remember correctly, a rectangle has a right angle. That makes it a right scalene triangle. So as you go through, you have to be able to recognize, where do I have my right angles, where do I have obtuse angles or acute angles, to be able to name all of these triangles.